The paper introduces a novel task called Generalized Open-Vocabulary 3D Scene Understanding, GOV3D, which extends the classic Open Vocabulary 3D Scene Understanding, OV3D, task to encompass a more general understanding of 3D scenes. This new task aims to evaluate the ability of models to understand abstract object attributes beyond object classes. To facilitate this evaluation, the authors propose a new benchmark named OpenScan, which is constructed based on the ScanNet 200 dataset and includes annotations for 8 linguistic aspects of object-related attributes such as affordance, property, type, manner, synonyms, requirement, element, and material. The proposed OpenScan benchmark allows for a comprehensive evaluation of existing OV3D models, enabling a quantitative assessment of their generalization capabilities in understanding abstract object attributes. 7 strong baseline methods were compared under the GOV3D task on the OpenScan benchmark, with results showing that current state-of-the-art OV3D models excel in understanding basic object classes but struggle to comprehend object attributes such as affordance and material. This highlights the importance of establishing a comprehensive and reliable benchmark to identify the weaknesses of OV3D models. The paper also provides a review of related work in Open Vocabulary 2D and 3D understanding benchmarks, including COCO, LVIS, ADE20K, Pascal VOC, Cityscapes, PACO, FGOVD, OVD Eval, OpenMask 3D, OpenScene, PLA, Region PLC, Open3DIS, SAI 3D, and mask clustering. These methods primarily focus on object context for 3D scene understanding and utilize powerful 2D segmentation models to generate 2D instances that are then merged into 3D instances. However, these methods only provide qualitative results for object attributes and lack a thorough evaluation of performance beyond object classes. The author's work aims to address these limitations by conducting a comprehensive evaluation that encompasses a wider range of object attributes. The OpenScan benchmark is a novel dataset for the Generalized Object Vision with 3D, GOV3D, task, which aims to enhance the understanding of 3D scenes in machine learning models. It consists of 200 object classes with over 1,500 3D scans, providing attribute annotations for each object. The attributes are categorized into 8 linguistic aspects: affordance, property, type, manner, synonyms, requirement, element, and material. These attributes are derived from both common sense knowledge and visual appearance annotations. The annotation process begins by leveraging a knowledge graph to establish associations between objects and various attributes. For instance, an object, bed, is associated with attributes such as, is used for sleeping, is a good place to lie, and is made of wood. This information is obtained through a knowledge base like ConceptNet. Subsequently, manual annotations are conducted to label the visual attributes of each 3D target object, including material composition. Annotators identify the primary material of the target object by examining different camera views of the scene and corresponding image frames. The attributes are then classified into the 8 linguistic aspects mentioned earlier. Each attribute is carefully verified with its corresponding object to ensure accuracy. The final dataset, OpenScan, combines these 2 categories of attributes, providing a comprehensive understanding of 3D scenes in machine learning models. This dataset is constructed based on the ScanNet 200 benchmark, which is composed of multiple 3D scenes with object-level class annotations. The evaluation of the GOV3D task involves comparing predictions with the ground truth label, using metrics such as mean IOU, mean accuracy, average precision at different IOU scores, and the mean of AP from 50% to 95% at 5% steps. The paper discusses the OpenScan benchmark, which extends the traditional OV3D task by focusing on object attributes rather than object classes. It presents a comprehensive evaluation of 3D instance and semantic segmentation models on this benchmark. The OpenScan benchmark statistics show a total of 153,644 attribute annotations across 347 attribute classes for 1,513 scenes. The evaluation of OV3D models, such as OpenMask 3D, SAI3D, mask clustering, and Open3DIS, highlights strong performance in the synonyms and material aspects but struggles in the affordance and property aspects. The results indicate that certain aspects like synonyms and material perform even better than object classes, suggesting the model's ability to recognize visual patterns and comprehend visual attributes beyond object classes. For 3D semantic segmentation, the models evaluated, including OpenScan, PLA, and Region PLC, exhibit poor performance on linguistic aspects with low MIOU and MACC metrics. The paper also discusses the impact of pre-trained vocabulary size on the GOV3D task, showing that while some aspects may benefit from increased vocabulary size, others do not exhibit significant enhancements. The research paper addresses the limitations of the OpenVocabulary 3D Scene Understanding (OV3D) task by introducing a more challenging task, Generalized Open-Vocabulary 3D Scene Understanding (GOV3D). To facilitate research on GOV3D, a large-scale benchmark named OpenScan is constructed. The benchmark consists of 347 attribute classes across 8 linguistic aspects. The paper evaluates the latest OV3D models on OpenScan, revealing challenges in understanding attributes beyond object classes. Experiments demonstrate that enhancing generalization capability can be achieved by utilizing query templates rather than scaling up the vocabulary size during training. The paper concludes by highlighting the potential strategies for improving OV3D models, including leveraging explicit relationship modeling within OV3D models and well-designed query templates. In the realm of artificial intelligence and computer vision, the OpenScan benchmark has been constructed based on ScanNet 200, encompassing 8 linguistic aspects such as affordance, property, type, manner, synonyms, requirement, element knowledge, material, and source. This benchmark aims to evaluate the capabilities of various models in understanding these different linguistic aspects. The Open3DIS model, which integrates both 2D and 3D information, demonstrates its ability to comprehend specific linguistic aspects like synonyms and material, but struggles with generating correct 3D masks for certain aspects, such as affordance. The model's performance aligns with its quantitative results across the 8 linguistic aspects. The experimental details of the OV3D models, including OpenMask3D, SAI3D, mask clustering, Open3DIS, OpenScan, PLA, and Region PLC, are also outlined. Each model utilizes different architectures and training sets, such as Mask3D, SAM, CropFormer, ISBNet, OpenSeg, and B15, N4, to generate image and 3D proposals, and extract features from images. These models are designed to enhance the understanding of linguistic aspects in vision language tasks. Qualitative results of the Open3DIS model on the OpenScan benchmark are presented, showcasing the model's strengths and limitations in comprehending various linguistic aspects. The model's ability to identify target objects and generate predictions for different aspects is evaluated, highlighting its potential for future improvements. Overall, the OpenScan benchmark and the OV3D models provide a comprehensive framework for evaluating and enhancing the understanding of linguistic aspects in vision language tasks, paving the way for more sophisticated AI models capable of interpreting complex language commands and generating accurate 3D scenes. In the context of Open3DIS, a qualitative analysis is conducted on the OpenScan benchmark, as depicted in Figure 6. This figure highlights the ground truth target object and the output in color. The affordance, output, and ground truth query terms are used to describe various properties and functions of objects, such as keeping food cold, being a source of illumination, or being soft. These terms also have synonyms like image element, which shares similarities with the original term. Moreover, certain requirements and materials are associated with these terms. For instance, the term water and sun indicates a requirement for an object's functionality, while wood denotes the material composition of an object. Furthermore, the term 88 keys signifies a specific requirement related to the object's design or purpose. The use of these terms and their properties in the OpenScan benchmark allows for a comprehensive understanding of object affordances and how they relate to real-world scenarios. by analyzing the outputs generated by Open3DIS against the ground truth. Researchers can evaluate the efficacy of this system in accurately identifying and describing object properties. This process contributes to advancements in machine learning models that aim to understand and interact with objects in complex environments. The results from the OpenScan benchmark provide valuable insights into the strengths and limitations of the Open3DIS system. They demonstrate the potential for such systems to enhance our understanding of object affordances and improve human-object interactions in various contexts. However, they also highlight areas for future improvement, such as refining the accuracy of object property detection and expanding the range of objects and scenarios that can be effectively analyzed. Overall, the qualitative analysis presented in Figure 6 underscores the importance of continued research in this field, particularly in terms of enhancing the precision and generalizability of object affordance detection models. As these models become increasingly sophisticated, they will play a crucial role in advancing robotics, computer vision, and other related fields, ultimately enabling machines to better understand and interact with their environment.